All right, guys, this is lesson 10.5. So 10.5 is talking about tangents. A lot of tangents. Remember, tangent is just a line that barely touches the outside of the circle. So RS is a tangent line. ST is a tangent line. They don't go through the circle. They just go to the very outside and stop. So I want you to take a few seconds right now and read this right here. Read this to yourself. All right, so in the first sentence, you learned what a point of tangency was. So in this example, what's a point of tangency? It's R1, R, and T. It's wherever there's a tangent line and wherever it touches the circle in one point is called a point of tangency. So if these two tangent lines come from the same exterior point, which in this example, they both come from the same exterior point at point what? S. And since they both come from point S and they go to a point of tangency, RS is congruent to ST. That's main idea number one. Main idea number two, so we just covered this one. Second one is if a line is tangent to a circle, it is tangent to a circle if and only if it's perpendicular to a radius. So if you look down here at number 2, this is a radius. So JK is a tangent line because it's perpendicular. It makes a 90-degree angle. JK and JH are perpendicular to each other. So in exercise 1, do they both come from the same exterior point? Yes, so if we want to find x, we just have to set those equal. X plus 3 is equal to 7. Therefore, x is equal to try 3. What's x? Yeah, 12. It's just the same exact thing. They're both tangent lines. They come from the same point. So they're congruent. If we go back to 2, this is a tangent line because it is perpendicular to the radius. So if it wants us to find x, I know it's a 90-degree angle, so I can use Pythagorean theorem and find the hypotenuse. So do that now. Yeah. Good. Try 4 and 5 and 6. The only thing about 5 is look at 5, please. Is that a radius? Yes, and the radius is how long? 21. Is y to a radius? Y to a? Yes. So it's also 21. So in order to use Pythagorean theorem, I need to know that that's a radius, so it's 21 plus 8, so this whole length of this side is actually 29. So finish up 4, 5, and 6. Number 4, I know that that line of tangent, the tangent line, is perpendicular to the radius, so it's 90 degrees. So to find x, I first had to find the whole thing, which was what? 39. So using Pythagorean theorem, y'all found that r to t, the whole thing was 39. But what's r to u? 15. So to find u to t, you had to do 39 minus 15, which gave you 24. What was 5? 20. And 6 rounded to be 29.41. You found that by finding your hypotenuse, because they are perpendicular. Okay? Alright, to page 5. Do y'all like having all of your notes at one time? Kind of. Some of you like to get ahead. I think Sydney did this whole lesson in class yesterday. Hey Sydney, if you're listening. Which is cool. I mean, if you're done and you understand it, go at your own pace. So, 10.5. This is the last part of 10.5. Now what we're doing is we're throwing polygons into the circles, or outside of the circles. Oh gosh. Why? It's okay. It's not that bad. So if you throw circles inside a polygon, or if you throw polygons, okay, the circle's in all of these. Okay. So basically what happens is when a polygon is circumscribed about a circle, all of these sides of polygons are tangent to the circle. So right here, GH is tangent to the circle. HJ is tangent. So it touches at one point and then moves on. So if you look at example right here, the triangle ABC. Every side of this triangle is tangent to the circle, which means, look at this right here. Ignore this. Isn't that like what we just did? It comes from the same point outside, doesn't it? Point B, both this side and this side come from point B. So if this is 6, what's this? 6. And then if you look at this side, same point on the outside, they both are tangent to the circle. So if AF is 12, so is AD. Same over here. So if this is 8, so is this. So if I wanted to find the perimeter of triangle ABC, I would have to add 12 plus 6 plus 6 plus 8 plus 8 plus 12. Which is 52. Alright, this right here. Look at just the top portion. If this is 13, what's this? 13. If this is 17, the outside that comes from the same point is also 17. If this is 10, the outside's also 10. So you're finding the perimeter, so add all those together. What's the perimeter? 80. Okay, but it also wanted us to find x. This line right here, it wants us to find x. So what's x equal to? 23. All right, y'all finish 1 through 6 as a group. We will go over it when you're done.